Hi dears, this is the correction of application 1. Let's start reading it. He said the following figure shows a particle m moving along a circumference of a circle of center O and radius r equal to 50 cm with a curvilinear abscissa s equal to the arc of I m 5t plus, this is pi over 4, okay dears? Okay. I is the origin of the arc. The positive sense is considered to be counterclockwise. Okay. Calculate S0 at instant t0, then deduce that m start from point A, which make an angle pi over 4. Let us check it. I wrote the given here, and I converted the given. The given was 50 centimeter, which means divided by 100, it will be 0.5 meter. Part 1, he asked me to calculate S0. I will substitute 0 instead of time. 5 times 0 is 0, plus pi over 4, I will have a pi over 4 meter. I can leave it. And since this S is equal to the central angle, then at t equal to 0, at t 0 equal to 0, this point m is at A. M is at A, since S0 equal to arc IA equal pi over 4. Part 2. He said, calculate the algebraic value of. Part 1, the velocity. Part 1. How to calculate the velocity? Velocity is simply S prime. So I have to apply a derivative for this expression. The derivative of t is 1. 5 times 1 is 5, and the derivative of a constant is 0. This will mean 5 meter per second. Part 2.1. He asked me acceleration. Here I can apply Pythagoras. Pythagoras said that a square equal to a tangential square plus a normal square. But a tangential, which is equal to the derivative of the speed, and the speed here is constant, this will be 0. While a normal is v squared divided by r. So let's substitute here. V square divided by r, all of it square. This is the answer of a normal, huh? And then a without a square will be, a normal will be v square over r. V square over r equal, and I can justify that since the motion is uniform circular, then a equal a normal directly, okay, without these steps. 25 divided by r, which is 0.5, then the answer will be 50 meter per second square. 2.3, the angular velocity. Part 3. The angular velocity is theta prime. Simply theta prime is v divided by r. V was 5 meter per second, and the radius was 0.5 meter. Meter with meter cancel. 10 radiant per second. Part 2.4. The angular acceleration, which is theta double prime. Part 2.4. Theta double prime equal to a tangential divided by, or the derivative of theta prime, which is 0, divided by r, and it's 0 divided by r, and it's 0. Radiant per second, or second square, or you can say that theta prime, double prime, is the derivative of theta, which is a derivative of constant, which is 0, radiant per second again. Okay, any method of these two. Part 3. He said deduce the nature of motion of m, then specify the sense of motion of m. Okay. The nature of motion, here I can use any justification I like. I can say Since v equal to constant, then the nature is uniform circular motion. Or since a equal a tangent, a normal, then it's uniform circular motion. Choose any you like. So part 3, the motion is uniform circular motion. Okay, since the angular speed is constant, or the speed is constant, and the trajectory is circular. The speed is constant, and the trajectory is circular. The trajectory is circular. Now, how to find the sense of motion? You have to look at theta prime. If positive, then the object is directed positively as indicated. If negative, then it would be negative. Sense of motion is positive or counterclockwise. Is positive since theta prime is positive. Part 4. In part 4, he said calculate the period of motion of m, then deduce the time needed by m to travel a distance of 2 meters. Let us find the period of motion first. How to find t? Even study by heart, or you can use a cross multiplication. The speed is the distance divided by time, we know. If the distance is 2 pi radius, then the time will be the period. I will apply cross multiplication. T equal 2 pi r divided by v. 2 multiplied by 3.14 multiplied by the radius, which was 0.5, divided by the speed, which was 5, and let's go. It's 0.63 seconds. Then he asked me, deduce the time needed to travel 2 meters. I will apply cross multiplication. I will say if the period corresponds to a perimeter of a circle 2 pi r, then the distance, which is 2 meters, will correspond to that time t. So I will apply cross multiplication. T will equal 2 meters multiplied by the period and divided by 2 pi r. 2 with 2 will cancel, and the period I get is 0.63 divided by the pi, which is 3.14, and the radius was 0.5, 0.4 seconds. And application 1 is done. In application 2, he said consider a particle m moving along a circumference of a circle of center O and radius 2 cm. I have to divide by 100 with angular abscissa. Theta equal t cube plus 5t plus pi in SI. Calculate the number of revolution of m performed by 2 seconds. Okay, this is application 2, and I have to write the given here for me aside that the radius is 2 cm, which will be 0.02 meter, and theta is t cube plus 5t plus pi in SI. And he asked me in part 1, calculate the number of revolution. He need n for 2 seconds. He gave me the time, which is 2 seconds. Okay, and he asked me to find n. There is a formula, theta equal to 2 pi n, or n equal theta divided by 2 pi. I will use it. N equal to theta divided by 2 pi. I have to substitute the 2 seconds in theta. Theta, which is t cube plus 5t plus pi divided by 2 pi, I will substitute the 2 seconds in it. 2 cube plus 5 multiplied by 2 plus pi divided by 2 pi, and don't forget here I have to use the pi as a 3.14, 3.37 revolution. you can use an integer for revolution. It's 3. Part 2. Calculate the angular velocity and the angular acceleration of m. The angular velocity, theta prime, is simply the derivative of theta. Okay, so let's do it. Derivative of t cube will be 3t squared. The derivative of 5t is 5. And the derivative of pi is 1. Sorry, pi is 0, since it's constant. So this is an SI. And he asked me to calculate the angular acceleration, theta double prime. Simply theta double prime is the derivative of theta prime. I have to apply a derivative again. Derivative of t squared is 2t, multiplied by 3 will be 6t, and the derivative of 5 is 0 in SI. Here note that theta double prime is a positive but not constant. Let's go to part 3. He said specify the type of motion. This type of motion, since theta double prime is just positive, so it's accelerated circular motion. Circular motion. If theta double prime, here a note, if theta double prime equal to 6, for example, only, I have to say uniform, since theta double prime is constant, but it's not constant. It's a positive variable, since theta double prime is positive. Part 4, determine the expression of the curvilinear abscissa, which will mean this is S, the speed, which is V, and the tangential acceleration. Let us start by each one. 4. How to find S? I have a relation between theta and, let me write it aside. Theta, don't forget that theta equal S over R. So S will be simply the multiplication of theta times R. So S equal to theta multiplied by the radius. Theta was t cube and the radius was 0.02. T cube plus 5t plus pi. I have to multiply them all by 0.02. They will be 0.02, 0.02 t cube plus 0.1 t, let me use this space, 0.06, 0.06 in SI. Now, how to find the speed? I can use theta prime. There is a relation said that theta prime equal V over R. So I can use V equal to theta prime R. V equal to theta prime multiplied by R. Theta prime already calculated, 3t squared plus 5 multiplied by the radius, which is 0.02. So it will be 0.06 t squared plus 0. And an SI unit again. And he asked me finally to calculate A tangential. A tangential, which is the derivative of V, or I can use theta double prime, because theta double prime equal A tangential divided by R. Any of these you can do it. Let us apply the derivative of V here. The derivative of t squared is 2t multiplied by 0.06, it will be 0.12t, and the derivative of 0.10. This is in SI unit. And in this case, the problem is done.